Imagine a time when there was nothing. No stars, no galaxies, no planets, no time, and no space. Just an infinite void. But in a fraction of a second, this nothingness exploded into everything we see today. The universe, as we know it, was born. Welcome to the story of the Big Bang Theory, the most extraordinary and mind-bending event in the history of our cosmos. Scientists have long pondered the origin of our universe. Where did it all come from? For centuries, this question remained shrouded in mystery. But in the 20th century, a radical idea emerged. A theory that suggested everything in our universe started from a single point, a singularity, a moment where the laws of physics as we know them ceased to exist. It was Albert Einstein's theory of relativity that first hinted at a dynamic universe, one that was expanding and changing. But it was a Belgian priest and physicist, Georges Lemaitre, who dared to suggest that this expansion could be traced back to a single, explosive beginning. Lemaitre's theory was revolutionary, but it needed evidence. Enter Edwin Hubble. In 1929, Hubble's observations of distant galaxies showed that they were all moving away from us, proving that the universe was indeed expanding. The further the galaxy, the faster it was receding, clear evidence of an explosive origin. So, what exactly happened during the Big Bang? Imagine all the energy, all the matter in the universe, packed into a space smaller than an atom. Then, in a trillionth of a second, this tiny point expanded with unimaginable force, releasing energy and matter into the void. In those first moments, the universe was a hot, dense soup of particles, quarks, protons, and neutrons, colliding at incredible speeds. As the universe expanded and cooled, these particles combined to form the first atoms, primarily hydrogen and helium, the building blocks of everything we see today. But how do we know this explosion actually happened? The answer lies in the cosmic microwave background radiation, the afterglow of the Big Bang, a faint signal that permeates the entire universe. Discovered by accident in 1965 by Arno Penzias and Robert Wilson, this radiation is the oldest light we can observe, a direct remnant from the birth of the universe. Over the decades, satellites like COBE and WMAP have mapped this radiation in incredible detail, providing us with a snapshot of the infant universe, just 380,000 years after the Big Bang. This cosmic baby picture reveals tiny fluctuations that would eventually lead to the formation of galaxies, stars, and planets. Today, the universe continues to expand, driven by a mysterious force known as dark energy. Galaxies move further apart, stars are born and die, and new worlds continue to emerge. But what does the future hold? Will the universe keep expanding forever? Or will it one day collapse back into itself in a big crunch? The answers to these questions remain elusive, but the story of the Big Bang offers us a glimpse into the grandest narrative of all, the story of everything. The Big Bang Theory doesn't just tell us where we come from. It connects us to the cosmos, reminding us that we are all part of something much larger, something truly magnificent. As we continue to explore the universe, who knows what new chapters will be written in this cosmic story? One thing is certain, the journey has only just begun.